Okay, let's continue. There are people shouting in the corridor, and as usual, I have the windows open because the door and the windows open because there's a nice breeze and I don't use the AC. So I'm going to take, as I said before, I'm going to take some material from the IPCC AR6 report that came out during 21-22, and I have many podcasts on the entire report already on my climate change course and a couple of other places, so you can follow up. But in this context of our perturbations, disturbances and disasters and the complexity of the human system, I'm going to add a few most salient points here as well. So climate change has impacted human and natural systems across the world, with those who have generally least contributed to climate change being most vulnerable. This I already said in many ways. Accumulated carbon is causing most of the warming, land use change of course as well. It's not like poor people are innocent, but they have been dragged along by the rich countries with all their lifestyles, emissions, innovations. So life has gotten better for all, but now we have to think how to make the responsibilities equal, but count for the most vulnerable who didn't contribute so much. Equal, but there is a terminology IPCC uses. Okay, synthesis of assessment of observed change in hot extremes, heavy precipitation and drought, and confidence in human contribution to the observed changes in the world's regions. If you are new to this kind of discussion on climate change and synthesis reports from assessment reports from IPCC, the Intergovernmental Panel on Climate Change, which sits under the UNFCCC that we have already discussed, then you should get used to the idea that these are negotiated. Large synthesis teams from across the world are put together, and then the reports are negotiated with the government representatives to indicate the confidence levels. So confidence in human contribution ranges from low due to limited evidence, or low due to limited agreement of different studies, and medium and high. So the three dots are high confidence in our attribution of the change to climate change, in human-induced climate change. So the dimensions of risk we already looked at in terms of hazard. So this is hazard, vulnerability, exposure, response. So this is hazard. So type of observed change since 1950s. The different colors increases, in these decrease, limited data and or literature or reports from those regions, and low agreement in the type of change. Is it up, down, and worse, better, and so on. So hot extremes including heat waves, pretty much everywhere there is high confidence that we have increased the heat waves since the 1950s. There are some places where there is no data, or there are low agreements in the type of change, which is surprisingly even in the US, North America, where there is good coverage. Central Africa makes sense, but you can see that there are many details. If you focus on South Asia, then South Asia has high confidence in increases in heat waves, but if you come to heavy precipitation, then the confidence is low. So precipitation is an issue in that sense of measuring. It's very sporadic and very local compared to temperatures, which are large scale and more continuous, so measured more frequently, more in more locations, easier to measure, and so on. So you have to keep these in mind, that we see some increases in heavy precipitation, but if you want to argue that they are strictly related to human-induced climate change, then many places, in fact you can see most places, have on this scale low confidence due to limited agreement between different studies in this case. Okay, that's just something to keep in mind in terms of droughts and floods and so on. But in the context of risk, you have to then decide, are you going to wait for statistical proof that this is related to human activity, or are you going to do something about human activity in terms of mitigation, so reducing emissions towards sustainable development as well, and adaptation, i.e. deal with the changes that are already happening. So that's a no-brainer in terms of dealing with the risks that are there. We talked about agricultural and ecological droughts, so you can see again the scale of increase is lower, and confidence is also lower in general. If you have low evidence of contribution to heavy rain, then it's going to translate to agricultural and ecological droughts as well. But again, risk. If you're having persistent impacts on agriculture and ecology, biodiversity, food production and so on, then you better pay attention and not worry about statistical significance of how changes are happening and what is causing them and so on. Every region faces more severe and or frequent compound and cascading climate risks. This is where the complexity comes in. Compound means you have multiple events happening, so you have a drought going on and then a heat wave comes in and washes out your water resources or damages whatever crops that are left there, and you run into water shortages, mortality of old people due to heat waves, and then in Nepal you have had earthquake followed by heavy rain, landslides, damage to agriculture, food security issues, water security issues, energy security issues, and so on. So these are becoming more common. So here we are looking at exposure to a coastal flooding event that currently occurs on average once every 100 years is now going to occur or expose more people. So this is increase in the population exposed to sea level rise from 2010 to 2040. So sea level rise happens. It's not like a bathtub rising. It's a dynamic pattern, so it doesn't increase everywhere across the globe, just like temperature doesn't increase everywhere across the globe or by the same amount. But nonetheless, when warming happens, cyclones and hurricanes increase, or they get stronger and grow faster in intensity, then the amount of water being swept in due to sea level rise is going to get worse as well. Okay, so those are the kind of things you have to worry about. So this is looking at how the increased numbers will occur. Population exposed in 2020 is shown in these gray figurines, and expected population exposure in 2040 under some particular scenario of future. If you are not aware of what this means, when we want to project using climate models, we want to project into the future how temperatures will warm with the continued emissions, and the emissions will depend on what we will do with energy systems, bioenergy, technologies, population growth, renewables, and so on. Then those are called scenarios, and we look at scenarios. Now they are called shared socioeconomic pathways. They used to be called special reports on emission scenarios. Then they were called representative concentration pathways. Now they're called shared socioeconomic pathways. They worry about sustainability, fossil fuel use in growth, and renewable energy deployment, regional conflicts, and so on and so forth. I have detailed podcasts as well on this in my climate course, but nonetheless, one of those scenarios, middle of the road scenario it's called, what will happen to climate in 2040 and sea level rise, glaciers, and what it will mean in terms of exposures. So these are 2040 exposures will be up 71% here, up 35% here, small island states up 57%, Europe expected to have 57% increase. There are uncertainties in these future projections which we won't go into, but it's again about risk. How do you want to plan for this potential risk without worrying about the uncertainties in them, right? Asia up 26%, Africa up 95% in exposure of people to sea level extreme events. Australia 52%, and so on. So these are not small numbers, and even if you don't have the local details, the numbers should be a wake-up call in terms of investing in reducing the risks. Of course, even if there is a sea level rise projection of 1 meter for, let's say, a city like Mumbai, if you want to protect against it, let's say with multiple activities like increased natural subaquatic vegetation like mangroves, artificial reefs, sea walls, and so on, how much you invest can depend on financial constraints and not so much on what the expected sea level rise is. So risk is faced with various ways depending on finance, expertise, other barriers like resistance to change, and so on. Plus, you're always going to have residual risk no matter what. So you have to also be prepared for residual risk in terms of what is acceptable and what is not acceptable, right? Increased frequency of extreme sea level events by 2040. So there is the slow sea level, chronic sea level rise over decades versus extreme sea level events where storms come in and create massive storm surges and so on. So frequency of events that currently occur on average once every 100 years is what is being looked at. So again, middle of the road scenario. Here are the scales. How the frequency will change for these events: annual, decadal, twice a century event, and no change. So obviously everywhere news is kind of bad, and you can see Maldives is a sitting duck over there, and so are all these small islands. Australia is quite vulnerable in terms of well, actually mostly no change, but twice a century events happening. Coasts of US, Central America, South America facing challenges, Europe facing challenges, and many islands as well. So again, it's good to have such numbers in front of you and keep them in mind for sustainable growth, because remember the other thing: sustainable development, nationally determined contributions under the Paris Agreement. Again, if you don't know, follow up on my podcasts. National adaptation plans and economic development, as opposed to just sustainable development, have all to be synergized so that you are actually able to prioritize and fund things to move everything forward. Example of complex risk where impacts from climate extreme events have cascading effects on food, nutrition, livelihoods, and well-being of smallholder farms. So particular communities being looked at for complex risks. So multiple climate change risks will increasingly compound and cascade in the near term. So more frequent and more intense extreme heat and drought will have reduced soil moisture and health impacts, will lead to food yield and quality losses, which will affect food prices, reduced food security, increased malnutrition, decreased quality of life, and can reduce labor capacity, which will feed back to quality of life because incomes will go down. It will create reduced households, which will be affected not only by labor capacity but also food yield and quality losses. That will affect again decreased quality of life, and you have multiple such feedbacks into the system, from reduced food security to decreased quality of life to reduced labor capacity and productivity, GDPs, and so on. So bidirectional compounding happens in some cases here, and unidirectional and contagion effect on multiple risks when you have such things. So if food yield and quality losses happen, food prices can improve, and that can affect supply availability, access, and reduced food security. So even if food is produced, how it gets distributed and sold. For example, when El Nino forecast was made early in the year, around February, March, April, India decided that it will stop export of wheat, sugar, and so on, even before the monsoon season started. The monsoon turned out to be near normal, but there were, of course, extreme events and so on. Nonetheless, there are a priori risk reduction measures taken, which affected Indonesia with its demand for sugar and wheat, and cascades into the global markets, and the farmers who would rely on exporting sugar and wheat would suffer as well. So you have really complex networked systems now, and all of them face challenges when you have not only extreme event but expected extreme event based on forecasts. So let's look at another one, climate change and health risks. So climate change affects health risks directly through climate related hazards like extreme weather events, heat, sea level rise, air pollution, vector distribution and ecology, water scarcity and reduced food production, which will cascade into health outcomes as we'll see in a minute. But you will also have vulnerability factors like demographics, geographical, biological and health issues, socio-political, socio-economic, health system capacity, gender and equity, which have feedbacks with climate hazards, and exposure, which depends on people and communities, health workforce, infrastructure, energy systems, water systems, food systems, health systems, and so on. And then you have health systems and facilities which feed into the health outcomes, where environmental threat and greenhouse gas emissions affect them through impacts on healthcare facilities, effects on health systems, and throughout these you have what are called nexuses between food, water, energy, transportation, health, and so on. So health outcomes are affected in terms of injury and mortality from extreme weather events, heat-related illnesses, respiratory illnesses, waterborne diseases, and other water-related health impacts, zoonosis, where habitat loss and human activities create jumping of pathogens from animals to people, which is quite common in terms of swine flu and so on. But you also have anthropognosis, where people are giving COVID to animals and so on. Vector-borne diseases, of course, vector latitudes changing, altitudes changing, as we said, with warming and extreme events. Malnutrition and foodborne diseases, non-communicable diseases, of course, asthma and so on. Mental and COPD, etc. Mental and psychological health is a serious issue under climate stressors, what we call chronic and acute stressors. So chronic stressors are background increases in temperature, decreases in rainfall or increases in rainfall, humidity, winter temperature changes, and so on. And then you have acute stressors like cyclones, floods, heat waves, and so on. Okay, so we'll come back and look at something called our processes of change. So we'll do that in the next podcast, but you get the idea of what this chapter is all about. We are looking at how the natural system behaves, how we are perturbing that, and how our behavior changes based on natural perturbations, and how those perturbations are interacting with our economic, social, healthcare systems, and so on, and then how our activities are feeding to the natural system itself. Okay.